Hi friends, welcome to our channel. Today we will discuss distance-based clustering. Okay, this distance-based clustering comes under unsupervised learning. Okay, now we have many different distance-based clustering techniques. Among them, one type of techniques are exemplar-based. That means that is a predictive one. Exemplar based means predictive one, and another one is without an exemplar. Without exemplar means that is descriptive one. Without exemplar means that is descriptive one. Now we will discuss this one, that is predictive distance based clustering. We will discuss this predictive distance-based clustering in this session. In the next session, we will move to descriptive distance-based clustering. Okay. So this predictive distance-based clustering has the same ingredients as that of distance-based classifier. That means the classifier, generally remember, the classifier comes under supervised learning. The clustering comes under unsupervised learning. The predictive distance-based clustering uses the same ingredients of distance-based classifier. What is this one? Suppose a distance metric. It uses the distance metric as used in classifier also, and along with a way to construct the exemplars based on some decision rule. That is, this is happened in classifier also. That is, what are the things that are present in classifier, the same things present in distance based clustering. One type is the distance metric, and another one is you have to construct exemplars based on some decision rule. Now the main difference is, in distance based classifier we have a target variable. But in this there is no target variable. That is the main difference. So that means here in this, the target variable is not present. So an absence of an explicit target variable, this is the main difference between distance based classification and distance based clustering. In distance based clustering we have no target variable. Simply we have to made assumption based on the distance metric. We are using some distance metric. So by using distance metric we will perform, that is we will learning the target. By using this distance metric we will learn the target. But what is the main important thing? We have to aim, that is we have to form the clusters. We have to design the clusters such that find that are the clusters are compact. The clusters are compact. So with respect to the distance metric, a simple thing is, the elements or the instances that are present within a cluster are more similar compared to the elements present with the outside the cluster. Present is outside the cluster. That is, we have to use such type of distance metric to make the clusters as very compact. Okay, this is the distance based learning. In this distance based learning concept, so the first one is the predictive distance based. For that one we will move to the first one, k-means algorithm. So the k-mean problem is an NP complete problem. So I think everyone know NP complete, NP hard problems. NP complete problem means simple thing. There is no solution. If you have solution, but there is no efficient solution for the given problem. There is no efficient solution. So what we required in the K means, we required a global minimum value. In simple scenario, I will explain this k-means in 2 points. Simple thing, we are given a large data set. the data set is divided into different number of partitions or different number of clusters, such that intra cluster similarity is high and intercluster similarity is low. That is, the elements present within a cluster are more similar to each other compared to outside the cluster. We have to find that. Now the given data set is divided into how many number of clusters. This identification of k is an important factor. So this k means is np complete problem. There is no efficient solution to find the global minimum. That is, it is difficult to find the k value. Okay. Now we will explain the algorithm. We will discuss the algorithm. How do we implement algorithm? Simply, what is the input? What we are providing? Input is a data set D, on which we have to perform clustering. A data set B belongs to the entire instance space. Now what is one more input? Number of clusters. That is, how many clusters you required. For example, k is the number of clusters. This is the input, and you have to produce some output for the algorithm. What is the output? Output is to form k clusters, to form k clusters, and each cluster have, this is the concept related to mean. So k cluster means how to produce. For example, mu1, mu2, and so on, mu k. These are the means. These are also belongs to instance space. This is input, this is output. Input and output. Now what is the process? Step 1. The process is also very simple. Among on their data set, initially, that is, at the first step, randomly initialize k vectors. So here randomly means that is completely your choice. You can use any terms. You can randomly initialize k vectors. For example, what are the k vectors? Assume mu1, mu2, and so on, mu k. This belongs to R power d. So I am assuming k vectors. Now, in the next step, what we have to do? Repeat. That is, some operation has to be repeated. What is the operation? From the data set, for example, from the given data set, for example, assign each x belongs to d. That is, x is an instance of a data set. X is an instance of a data set. Now this x is assigned to this cluster. For example, here what is the meaning this one? We have k clusters. Assign the instance to the nearest cluster. That is the important thing. Assign the instance to the nearest cluster. How can you say that which one is the nearest cluster? Based on Euclidean distance. That means what I am doing? Simply from the data set, bring one instance and calculate the distance from this instance to already assumed means. Okay. So among all these, select which one has the smallest distance. That is, so we have to assign each instance to or min. Why? We have to consider minimum distance. Suppose dis to x comma mu j. Dis 2 means this is called Euclidean distance. So we have to find the Euclidean distance between x to each and every one. That means x to u1, x to u2, x to u3, and so on, x to uk. Find x to all means. Which one is the smallest? For example, if x to u2 is the smallest one, if x to u2 is the smallest one, now we have to assign x to that particular mean. Now after calculation of these distances, now the same procedure is repeated for each and every cluster. We have k clusters. So for j is equal to 1 today, the same thing. What is the thing? X This is the data belongs to D. Now we are calculating the minimum distance. So it is assigned to, for example, this is assigned to assigned to cluster J. Assume not J means a cluster J. That means what is DJ. For example, D is the entire data set. The data set is divided into D1, D2, D3, and so on, dk. That means we have k number of clusters. After calculation of third step, we have to assign the instance x to cluster dj. Now, what is the next step? Once we assigning a value to the cluster, again you calculate the mean. Again, you have to calculate the mean by including that one. By including that one. So, what is the mean? Simply, mu j is equal to total number of elements of the cluster. Cluster name is dj. Total number of elements of the cluster. For each x belongs to dj, x x. That means sum of all the instances by mean. Sum of all the instances by mean. And we have to implement the same thing for all the k clusters. All the k clusters. Now, the fifth point is this operation. Here I am writing repeat. When to stop? This operation is repeated until no change in means, that is mu1, mu2, and so on, mu k. Finally, in the sixth step, we have to return. In the sixth step, you are written mu1, mu2, and so on, mu k. So this is the concept in simple scenario. For example, this is the data set which contains some number of instances. What is the first step? I am assuming k value as 2. K is equal to 2. For example, these are different instances. This is one cluster. This is one cluster. Randomly initialize k vectors mu1, mu2, mu k. Suppose this is one random point. Assume this is another random point. These two are the two random points. Now what is this in? For example, this is an instance. Calculate the distance from this instance to this mean and this instance to this mean. So among these, we have to consider the minimum one. For example, if this is the minimum one, assign this instance to the cluster. Now these two forms a cluster. That is the fourth step. For all the clusters, we have to do procedure. X belongs to D. That means the X is added to cluster DJ. Now, what is that one? After adding this one, actually, what is the mean? Simple thing. Mean is the centroid. The centroid of the cluster is changed. Initially, here it is the centroid. When I am adding this one, you have to modify the centroid. For example, now the mean becomes this position. The mean becomes this position. The process, so not only for this one, for all the instances, we have to do the same procedure, and the procedure is repeated multiple number of times until there is no change in the mean. That means after adding element also, the mean does not change. The mean does not change. That is the final position. That is the final position. Okay, this is the k-means algorithm. This is the k-means algorithm. Okay, generally in along with the k-means algorithm, in k-means algorithm we have to remember one point. We have to remember one point. So generally one iteration of k-means never increase. One iteration of k-means never increase within cluster scatter. So multiple number of iterations only increase the similarity. Multiple number of iterations only increase the scatter. So that means by repeating multiple number of times, the algorithm generally reaches a stationary point. You have to repeat the algorithm multiple number of iterations. The algorithm reaches stationary point. What is the meaning of stationary point? The last one. That means a point where no further improvement is possible. A point where no further improvement is possible. In that case, we have to stop. In this case, we have to stop. And the last point regarding k-means means even though generally the k-mean converges to stationary point, K-means algorithm converges to stationary point in a finite amount of time. That means the stationary point in the sense the means are not changed. That is fixed. Even though it produces, there is no guarantee of the algorithm produces the global minimum value. There is no guarantee. There is no guarantee. Why? They are calculating the mean of the cluster that they are not changed. Now, to overcome this one, along with K-means algorithm, one more technique is implemented in predictive distance-based clustering. Predictive distance-based clustering. So, what is that one? I am moving to next one. That is called medoids. So, that is called K-means medoids. That means we have to perform clustering based on the medoid concept. Okay. So what it requires simply it requires the exemplars to be data points. So if you want to calculate medoid between the some set of elements, you have to assume each and every exemplar as a data point, and the main difference between mean and medoid is, remember, the main difference between the mean and medoid is, to calculate medoid of a cluster, if you want to calculate medoid of a cluster, you have to examine all pairs of points in the cluster. You have to examine all pairs of points. For example, these are the points. So how to calculate medoid? This one, this one, this one, this one, this one. So all combinations have to be considered. But if you want to calculate means, if you want to calculate the means, it simply requires a single pass. That means from this point to mean, this point to mean, this point to mean, only single pass through the points is required. Through the point is required. Okay. Okay. Now this is the k-medoid algorithm. The procedure is completely same. I will explain the algorithm. What is the input here? Simply the input is data that is also from the instance space, and also number of clusters k, and also k number of clusters. Okay. And here all you are using in the previous k-means algorithm, we are using Euclidean distance as a metric, as a distance metric. Suppose in this we are using some arbitrary distance metric, for example DIS. So in this I am using arbitrary distance metric DIS. This is the distance metric, simply x into x. What is the output? Output is almost same. So in the means we have getting k means, that is mu1, mu2, mu3. Here we are getting k medoids. Both compare the algorithm and then write, then it is very easy to remember. So the input and output are both same. The only difference is instead of k means, here we are getting k medoids. Okay, the k medoids are the same, u1, u2, and so on, mu k, that belongs to the data set. That belongs to data set. So what is the first step? The first step is the same thing. Randomly pick k data points. Randomly pick k data points, that is mu1, mu2, and so on, mu k, that belongs to D. That is, among the entire data set, you pick k data points. These are assumed as medoids. My assumption is these are assumed as medoids. In the previous one, these are assumed as mean. Now, you have to repeat a procedure. Now, what is the third step in this? Select a point, suppose assign each x belongs to D. What is, we have to calculate the distance from the point to each and every medoid, distance from point to each and every medoid. So same argument j of dis of x comma mu j. Here the only difference between k-means and this one is, in the k-means we will write dis2, that is Euclidean distance, but you are using some arbitrary distance. Once you calculate the distance, you have to repeat the process. Suppose for j is equal to 1 to k for all the medoids, What to do? Assign to the cluster J the same thing. The X belongs to D such that X is assigned to cluster J. That is, among all these, x2 mu j is the smallest value, that is the smallest distance. Now x is assigned to gj. Up to now it is a completely same. Now what we are doing in k-means algorithm, whenever we are adding an instance to the cluster, we have to calculate, that is recompute the mean value. We have to recompute the mean value. Then here what you do, you have to recompute the medoid value. So mu j is equal to, how do you calculate the medoid value? This is the difference argument of, you have to medoid value, we have to examine all pairs of points, examine all pairs of points for which one, for cluster dj, that is each individual cluster. So x belongs to dj, x is an instance of cluster day, x is an instance of cluster day. Sum of x dash belongs to dj, dis of x comma x dash. That means what is this one? Each and every element, consider one point, x is one instance, x dash means remaining all instances. That means, for example, these are the points. If this is x, this is x, so here sigma x dash belongs to dj means this is x dash. Calculate the distance from this to this one. In the next iteration, distance from x to this one, x2 x3 x2 x4 x2 x5, like this we have to calculate all the distances. Among them you have to select the minimum one, that is the medoid. In k-means we are calculating just an average, but you have to examine all the pairs. This point is reflect on this fourth equation. The same thing, repeat the process until no change in medoids, that is mu1 mu2 and so on mu k. Finally what is the answer? Return mu1 mu2 and so on mu k. This is the only additional step, is this one. This is the only additional step. This is the k-medoid algorithm. Okay. Now, along with the k-medoid algorithm, we have another algorithm also, that is partitioning around medoids. That means what we are doing here, we are not performing any partition. First, I am randomly pick some points as the medoid points, assign the points to the nearest medoid and recompute the medoids. Now, for this, an alternate one is partitioning around medoids, so also called as PAM. This is an algorithm. So what this algorithm do? Simply this algorithm improves the clustering, improves the performance of clustering locally by what the main point of view, it perform swapping of medoids, swapping of medoids with other data points. That means the medoid is not fixed. This partitioning, this PAM algorithm, it improves the performance by swapping the medoids and other data points. Both are swapped. By this, the quality of a cluster is to be calculated. So, for example, if Q is the quality of a cluster, the quality of the cluster is calculated. How we are calculating? Simply based on the distance. So, the total distance, the quality of a cluster Q is calculated, the total distance over all the points, remember nearest to the, all the points to the nearest medoid. The quality is calculated by calculating the total distance of all the points to the nearest medoid. Nearest medoid. This is the way we will calculate. So generally, before going to algorithm, what happens? For example, if you have k number of clusters, what to do? If you have k number of clusters, what are the remaining number of instances? Remaining number of instances are n minus k. That means we have k into n minus k pairs. K into n minus k pairs of one medoid and one non-medoid. Okay, so K are the medoids, N minus K are the non-medoids. So these are the different pairs that forms. Each pair contains one medoid and one not medoid. And by using these pairs, we will calculate quality. By using this pair, we will evaluate the quality. And how many number of times we have to repeat? You have to repeat the loop n minus k times simply all the instances that are not medoids, all the instances that are not medoid. So simply I will explain the algorithm. The algorithm is the input is same. What is the input? Input is, suppose I will write down in the new slide. Input is the data from the instance space and the number of clusters k. Number of clusters k. What is the output? Output is k-medoids. But what is the difference? So in the previous one, this one, the main difference is in this partitioning around medoids, it performs the partitioning and it also calculates the quality of the cluster. Quality of the cluster. So what is the first part of the algorithm? First part of the algorithm, suppose the same thing, randomly pick k-medoids. Randomly pick k-medoids. That means instead of medoids, we have randomly pick k data points, mu1, mu2, and so on, mu k. Data points means these data points are assumed as medoids randomly. Now, the same steps. The first part is same step, repeat, assign each xi, that is each instance of D, we have to calculate the distance. So, dis of x comma mu j, the same steps from the instance to that particular medoid, we have to calculate the distance and repeat the loop how many number of times? J is equal to 1 to k, we have k medoids. And what is the next step? Assign the instance to cluster j. Assign the instance to cluster j, that is x is assigned to cluster j. So all the three algorithms up to now the same procedure here end. Now here we have some modification. So in the k-means algorithm, after assigning, we will calculate the mean value. In the k-medoid algorithm, we will calculate the k-medoid value. But in this, we have to calculate quality. Just now we discussed how do we calculate the quality? Simply the distance between every pair of elements. Distance between every pair of elements. Suppose x is the instance that is already assigned. Sigma x belongs to dj. That is, x is an instance of cluster dj. You have to find the distance between x to mu j. So from that instance to all the mean, okay, that operation is repeated. That operation is repeated for all the clusters. This operation is repeated for all the clusters. And finally, take the sum. Finally, take the sum. This Q is the quality parameter. Q is the quality parameter. Then after that, what you do? We will calculate medoids also. For each, assume for each medoid M, and so in the previous we discussed n into sorry k into n minus k pairs. Each pair contains one medoid, one non-medoid. So for each medoid M and for each non-medoid O, that means I will consider pairwise. One is yes medoid, another one is not medoid. What to do? So the main thing of this PAM algorithm is perform swapping operation. That means the medoids are swapped with non-medoids. This is the only point. Single point is the medoids are swapped with non-medoids to improve the quality. That means, so assume M is the medoid, O is the non-medoid. Then what I am doing? Calculate improvement in Q. Calculate improvement in Q. So resulting by swapping M with O. That means if you are swapping the medoid and data point, if there is any improvement, in the quality of the cluster, perform swapping operation. The process is repeated for all the pairs. The process is repeated for all the pairs. The finally select the pair with maximum improvement. Among all the pairs, we have to select the pair with maximum improvement. Okay, and finally perform swap operation. The same thing, only these 5, 6, these are the additional points. So what is the additional point? You have to perform swap operation. After performing swap operation, again calculate. That is, the performance of the algorithm is improved. The process is repeated until no improvement is possible. Finally, we have to return these values mu1, mu2, mu k. So these three are the predictive based distance, that is the predictive distance based classifier. Predictive distance based clustering. K means k-medoids and PAM, that is partitioning around medoids. Now one more point related to distance based clustering is sillhuttes. The main purpose of this one is to detect the poor quality of clustering. The main purpose of this sillhuttes is to detect the poor quality of the clustering. Okay, so they are assuming some general notation. Based on the notation, they will discuss the quality. Based on the notation, they will discuss the quality. So what are the notations? For example, xi is any data point. Now d of xi comma dj, what is the notation? D of xi comma dj is simply the average distance, from xi to all the points of cluster dj. We already know dj means cluster dj. D of xi dj is the average distance from xi to all the points, all the data points of cluster dj. Suppose j of I is index. J of I is index of the cluster. The index of the cluster that xi belongs to. That is, to which cluster the data point belongs to, that index is represented with ji. So two more notations. One is a of xi. That is the inter distance and intra distance. We have just now discussed in the starting of the session, intra distance and intra distance. A of xi is equal to xi dji. That is, what is the meaning of this one? The average distance of xi to xi, the average distance of xi to the points in cluster dj only, dji. That means within cluster dj. So finally one more notation is b of xi is equal to in k not equal to j of I, d of xi comma dk. What is the meaning of this one? B this average distance to the points in neighboring cluster. You got the point? A of xi means the average distance within the cluster. B of xi means the average distance to the neighboring clusters. Now after assuming all these notations, generally what is our expectation? A of xi value. So distances, we are calculating distances, means generally A of xi value is smaller than B of xi, right? Why? This is within cluster, this is between different clusters. Obviously B of xi value is more, but in some situations it is not guaranteed. So what we will do means simply take the difference between the two distances b of xi minus xa of xi. These differences indicates how the cluster is defined, that is the cluster is well formed or not, the cluster is well formed or not. Suppose if the value is greater than means we are dividing with b of xi, we are divided with b of xi. Suppose in some situations, if a of xi value is greater than b of xi value, so that means the difference is negative. The difference is negative. That means what is the meaning of this one? The members of the, that is on average, the members of the neighboring cluster are closer to xi than the members of the original cluster. That means if this is the case, if this is the case, suppose these are the members of axi, these are the bx, the members of this cluster are closer to this one, are closer to this one. Okay, that is the meaning. A of xi smaller than b of xi means it is well formed. But if the reverse case means this cluster values points are closer to this cluster, so on that case we will take a normalized value. In this case, what to do? Simply you divide with a of xi to get the fractions. So generally, if you don't know whether which one is correct, either a greater than or b greater than, simply we will do a normalized equation. So of xi is equal to p of xi minus a of xi by, we will take the maximum of 2. Okay. Based on this point, this is sillhutte coefficient. Based on this sillhutte sorts the values, whatever the values we are getting, sorts the values and plot a graph. And plot a graph for each instance, depends on cluster, that is cluster by cluster. For each instance it plots a graph. Suppose if the graphs are, that is after drawing the graph, suppose if they are less have, if it does not have sum of squared error, generally we are called it as ssc, we will call it as ssc, sum of squared error is to be minimized. Generally if you are applying Euclidean distance, the value of ssc is minimized. That is by using these xi values we will prove whether it maintains the well clustered or not. So this is the predictive distance based clustering. Briefly discuss the k-means, k-medoids and partitioning around k-medoids. Almost three algorithms, 90% is same, only some modifications. In partition we have one more step is quality. For quality we have to swap medoid element and non-medoid element, and to check the quality, poor quality, we are using the sillhuttes. Thank you.